Check. Ah, once again. Can you guys hear too much of a background noise? If you can let me know something about that. Because I always feel that I'm sitting in a sort of a noisy environment. Uh, and I'm not sure whether my voice gets a little disturbing because of the noise in the background. So only you guys can give a feedback about that. In whatever classes that you have attended so far, have you ever felt that there's too much noise coming from the background? Because if you're not saying that, if you're not complaining about it, I'm assuming that it's really not making a difference. Like you are able to hear me properly, and there are no issues as such. So since I've not got any complaints about my audio, I would like to assume that there is no issue as such. But in case you feel that something can get better, feel free to let me know. I hope you guys have answered this question to yourself, uh, as I had asked you yesterday, how to find determinant, of a 3 by 3 matrix, right? I had asked you to look about it on YouTube, because we will be using this concept, this formula, whatever, to uh, you know uh, solve some problems today. So if you haven't, maybe you will get it through the problems itself. And regardless of that, I would still prefer if you guys read and solve some problems related to finding determinants of a 3 by 3 matrix on your own. Anyways, you will study this chapter called as matrices in mathematics. I think it's towards the end of 11th, right? It's a part of your 11th syllabus, but I guess it's towards the end. Uh, and here everything will be clear about what a determinant of a matrix is, and all those things, all properties of determinants also. It's a very important chapter, important section, important chapter of maths, but probably not as important as vectors or calculus as far as physics is concerned. So in physics, we do not require heavy knowledge of matrices. A very basic knowledge also would do. But we need to have some good knowledge on calculus and vectors. Vectors and calculus, as also as I have been repeatedly saying, these are not chapters of physics originally. Vectors and calculus originally are chapters of mathematics, but they are so important from physics point of view that we study them separately as a part of bridge course, because without the knowledge of these, you will start struggling from the first chapter of your physics itself. Whereas matrices, not so useful as far as physics, as far as its application in physics is concerned. It is an important chapter from maths and maths questions point of view, but not as important as vectors or calculus as far as physics is concerned. So hello Akshat, good afternoon. Usually it's only Akshat who is active on the chat. There are some other people also who occasionally keep coming and going, and they keep putting messages, but it's not really a regular thing. I'm not sure, maybe they are attending live classes, because I do not see any dip in the maybe they are attending recorded lectures and not live classes, because I do not see any dip in the recorded lectures views. In fact, it's only been steadily increasing over time. Uh, so the audience is retained, but for some reason people are not really sitting live from 12 to 1. That's fine. It's just a personal suggestion, but it's always better if you come live. So today we will, spend some time doing problems on vector product. So today's agenda is number 1, doing some problems on vector product and its properties. we've studied a lot of theory about vector product in the last 2-3 days, and also about its properties. We saw so many properties yesterday. So we will do some problems based on this, and then we will have a introduction to calculus. This introduction will be very conceptual in nature. It will be more like a conversation and less like problems and mathematics. It will be more like a story, right? So stay tuned until the end. Excuse me. Actually, I remember even before I started studying calculus, I had heard about it from one of my uncles. So I had an uncle, and back when I finished my 10th, I spent some time with him at his place, and I remember him telling. I remember him explaining me the importance of these engineering exams, and if you end up doing well in these, then how your life can possibly be, all those things. Like he told a lot about all those, and then he also told calculus was one of those topics in his 11th and 12th which he still doesn't understand. He used to tell this. He even after so many years, back then also he did not understand, and even now if it comes across him, he's clueless about it. And that was the day when I developed a perception about this topic, that it's going to be difficult. If somebody randomly comes and tells you that everything is fine, but calculus is that one chapter which I don't really understand, I never understood in my time, then you will also have this perception that indeed something is difficult about this chapter, or about this whole. Calculus is actually a combination of. Actually, it's a combination of some 7 to 10 chapters. 7 to 10 chapters together are known as calculus, but that is that is from mathematics point of view, from maths point of view. But if you study calculus from physics point of view, it is just one chapter. From physics point of view, it is just one chapter, because we will just pick up the basics of these 7 to 10, and we will study that in one chapter. But when you study the same calculus in mathematics, then it's very intensive. In fact, out of your 2 years of preparation, roughly 35% is calculus. 35% of your time and energy and the questions in your paper is calculus, which is a lot of time. When you look at the time frame of 2 years, 35% of time, energy and number of questions coming from one section tells you that that section is very intensive. And that's how calculus is from mathematics point of view. But from physics point of view, as I told, from these 7 to 10 chapters, we will just pick up all the basics that we need for physics, and we study that as a part of one chapter. And at least this one chapter that you study from physics point of view should not be difficult. It should not be difficult. However, when you study calculus from maths point of view, things can get very different. In fact, I was told by my mathematics teacher that the section which differentiates rankers from non-rankers in mathematics is calculus. The section which differentiates rankers from non-rankers in mathematics is calculus, which tells you that not everybody gets it. Not everybody gets this 35% right. Okay. So when you study calculus from mathematics, you will have some chapter 1 you will have functions, chapter 2 you will have limits, chapter 3 you will have continuity, chapter 4 you will have differentiability, chapter 4 you have applications of derivatives, chapter 5, chapter 6 you will have indefinite integration, chapter 7 you will have definite integration, chapter 8 you will have areas, chapter 9 you will have maxima, minima. Actually, maxima, minima is a part of applications of derivatives. Chapter 9 you will have differential equations. So this is like 9 to 10 chapters. So when you study this in mathematics, make sure that you understand every chapter, because if you don't understand functions, you will not understand limits. If you don't understand limits, you will not understand continuity. If you don't understand continuity, you will not understand differentiation. This is from mathematics point of view. From maths point of view, calculus is built like this. Like it starts with functions, then you have limits, then you have continuity, then you have differentiability, then you have applications of derivatives, then you have indefinite integration, then you have definite integration, then you have areas, then you have differential equations. So I can say except differential equations, all of these are built on top of each other. All the other 8 chapters are built on top of each other, which means functions is the most basic thing that you need to understand the ones which are above it. If you want to understand indefinite integration properly, you need to know functions, you need to know limits, you need to know continuity, differentiality, everything below it, right? If you need to know a certain chapter from this deck, you need to know all the chapters below it properly. So this is how you will have to study calculus from maths point of view, but from physics point of view, it's very limited. We will just, extract basics from these 8 chapters and we'll just make it as one chapter. And that one chapter will not be very difficult for you. So this is one thing which I wanted to tell you before beginning introduction to calculus. Anyways, first let's get back to some problems on vector product. So if you guys have understood stuff, let's see. Question number 1. Find a, this is a very popular model, very popular, or that's why it's a very important question also. Focus on this, okay? Focus on this question. Find a unit vector perpendicular to a bar is equals to 2i cap plus 3j cap plus k cap, and b bar is equal to I cap minus j cap plus k cap. Now, read the question and first tell me whether you are able to understand what this question means or not. That is the first thing. Step 1 is to first understand what it means. Second question is to get an idea. Get an idea about how you can solve it. What are the various steps which you will have to go through to solve it. Third is execution of the idea. Right? So here in the execution part, your math will come. Here is where your math will come. And these two is where your physics will be in place, right? So that's why you should know physics is never an independent topic. Physics without mathematics makes no sense, right? You will very much realize that throughout your 11th and 12th preparation that physics as a subject without mathematics will not make any sense, because to solve every physics problem you need a good amount of mathematics. So execution part of any physics problem is mathematics, but the first two parts, which is understanding the problem and getting an idea, is basically testing how good your physics concepts are. So let's look at what this problem first means. Let's first understand this problem and then we will see if we have an idea to solve it. Let's see. So first problem is find a unit vector. Okay, I need a vector of magnitude 1 unit which is perpendicular to this vector and this vector. So I don't know how a bar and b bar are. So maybe a bar is like this, maybe b bar is like this. They are given in component form, they are not given in the graphical form. So I don't know how they are going to look. But let's just draw a rough diagram. But I need a vector which is perpendicular to both of these. This vector, red vector, is perpendicular to both a and b. In other words, yeah, can we make cross product? Exactly. That is what we will have to do, Akshat. Because when you take cross product of a and b, that's the idea. Okay, so first we understood what the problem means. What did we understand? We have two vectors a and b. We need that vector which is perpendicular to both a and b. We have understood what the question is asking us to do. Now we have to look into our physics reserve. What does physics reserve mean? What does physics reserve mean? Everything in physics that you have studied so far and understood, you will have to look into that and see if there is any concept which can be used from that reserve to solve this problem. So my reserve tells me that so far I have studied about units, dimensions. Units will be used here? No. Dimensions? No, nothing to do. Can I use vernier calipers or anything like that? No, it's a different thing altogether. Vectors. Okay, this question is about vectors. So let me go into vectors. Now, this vector is asking me about finding a vector which is perpendicular to two vectors. How can I do that? If I have two vectors with me, how can I find a vector which is perpendicular to both of these? Okay, when I studied cross product, then remember how my screw was? When I study A cross B, then A cross B is a vector whose direction is perpendicular to A and B. Now to get this idea, you have to understand cross product that well, because only then it will click you. Right? So, right. If you remember, A and B, they make up a plane. You have to put a screw which is perpendicular to this plane, which means this screw is perpendicular to both A and B. So my cross product vector, which will be along the movement of the screw. Remember, if I rotate from A to B, it will go down through the smaller angle. If you rotate from B to A, it will go up. So your cross product vector will either be up or down, right? Cross product vector will either be up or down. So okay, using cross product, I can get a vector which is perpendicular to both A and B. But what is the guarantee that that vector will have unit magnitude? There is no guarantee, no. Because if I take cross product of A and B, one thing is guaranteed. If I take cross product, I will get a vector whose direction is perpendicular to A and B. It can either be up or down. That we will have to see using screw rule. But as far as magnitude is concerned, how do you get the magnitude of A and B? Isn't it mod A mod B sine theta? Right? It is mod A mod B sine theta. So here you will, in this red bracket, you will have mod A mod B sine theta. Now, is there a guarantee that this mod A mod B sine theta will always be equal to 1? Is there a guarantee? No. It might or might not be equal to. Like equal to is also possible, not equal to 1 is also possible. It depends on the value of A, B and theta. Right? So, we are not sure whether cross product will give us the magnitude 1 or not. We are sure that cross product will give us a vector which is perpendicular to A and B, but I need a unit vector which is perpendicular to A and B. And I'm not sure whether A cross B will give me a vector of magnitude 1. So what will I do? How will I get the unit vector? How will I get the unit vector? So my unit vector, I can get it like this. First I will take A cross B. This A cross B vector will give me a vector whose magnitude is mod A mod B sine theta, whose direction is perpendicular to A and B. If I divide this with mod A mod B sine theta, if I divide this vector with this, then I will get a unit vector, right? Are you guys convinced with this? If you remember, if you have a vector A bar, and if you multiply this vector with 1 by lambda times A bar, then this vector will get resized, correct? It will get resized to have magnitude of 1 by lambda into mod A. That will be the length of this resized vector. So if I have a vector A bar, and if I divide A bar with its own magnitude, then what will I get? I will get a unit vector in the direction of A bar. Because what am I doing? A bar is nothing but mod A bar into direction, right? And if I divide with A bar with mod A bar, then mod A bar will get cancelled. I will only be left with direction, and I have been repeatedly telling you that direction itself means a unit vector, correct? Direction itself means a unit vector. So how do you get a vector which is perpendicular to both A and B? Simply do A cross B and divide that with the magnitude of A cross B. And what is the magnitude of A cross B? What is the magnitude of A cross B vector? It's simply mod A mod B sine theta. Right? By definition itself, it's mod A mod B sine theta. So you will just have to take A cross B and divide that with mod A mod B sine theta. Right? So I have A available with me in the component form. I have B available with me in the component form. Can I use this knowledge? I can. So let me, you know, just clear all of this. And let's go back to that page where we have A and B with us. This is my A, this is my B. Okay, I need to find A cross B for two vectors which are not available in graphical form but in component form. What do I do if vectors are in component form? I told you in the previous class, you need to construct a 3 by 3 matrix. Whenever vectors are given in component form and not in graphical form, then your screw rule and all those things will not come into use, because to use screw rule you should be able to see the vectors. Only then you will join them, place the screw, and do all that. But if you're not able to see them, then you will have to use matrix, right? That matrix method to find cross product of A and B. Okay, so let's do that then. How do you find A cross B? First you will construct a 3 by 3 matrix, and first row is always fixed. What is the first row? I cap, j cap, k cap. It is fixed. What should be the second row? Since I am doing A cross B, I will put the components of A first in the second row, right? Which is 2, 3 and 1. 2i, 3j, 1k. So 2, 3, 1 are the magnitudes of the components, or the value of the components, you can say 2, 3, 1, right? Because if it was minus k cap, I will not say magnitude of z component is minus 1. No, magnitude of z component is 1 only, but that 1 is pointing in the negative z direction. Okay, so let me say value of components 2, 3, 1. Then you will put components of B in the third row, which is 1, minus 1 and 1. Okay, there is a minus 1, so you will have to take that minus. Okay, 1, minus 1 and 1. And remember, in the first column you will only put x components. Do not, like if your vector A bar is written as 3j minus 4k plus 2i, then don't end up putting 3 minus 4 2 here. Okay, first column will only have x component, so x component is 2 here, so you will have to put 2 only. I hope I made some sense. What I was trying to say, if that vector A bar is written in a different way, right? So right now your A bar vector is written as 2i plus 3j plus k, right? If I write this vector as 3j plus 2i plus k, is it wrong? Is it wrong to write this vector like this? No, both of them are right, and both of them are in fact the same vector. But when you make this matrix for finding cross product, then you have to make sure that below I cap you are only having the value of the I components, which means only x components. So if you end up picking 3, and if you, instead of putting 3 here, if you put 2, instead of putting 2, if you put 3 and then you put 2 here, let's say, instead of 3, and instead of like 1 is 1 only, then this is wrong. You should not write the matrix like that. It is a mistake. You will have to pick up the x component and you will have to put that in the first column. Below I cap you are supposed to put x component. What is the x component? If you look at this arrangement, x component is this, right? The one which is next to I, that is your x component. So you will have to put 2 here. And then below j you will put y components, which is 3. Below k you will put 1, that is fine. So whether your vector is written like this or whether it's written like this does not matter. You have to be very careful when you construct this row. Okay, do not make that mistake. I hope I made sense. Now since your matrix is ready, you can just use the determinant method, or basically find the determinant of this matrix, and that is your A cross B vector. How will you find determinant? I cap into cross multiplication 3 into 1 minus 1 into 1 plus j cap into, this time you will have to do cross multiplication from 1 to 1 and 1 to 2, right? So 1 into 1 minus 1 into 2, And if this method is not making sense to you, please go on YouTube and find and search for how to find determinant of a 3 by 3 matrix after this class. Okay, do not leave the class in the middle and go. So I'm doing something, I'm doing some mathematical operation to find the determinant. If you know this mathematical operation, you will know what I'm doing. If you don't know this operation, you will have to go and see how to find determinant of a 3 by 3 matrix to know this step, whatever I'm doing here. So k cap into 2 into minus 1 minus 3 into 1. And this, let's see what this is going to give me. A cross B is 3 plus 1, 4 I cap, and then 1 minus 2, which is minus j cap, and minus 2 minus 3, which is minus 5 k cap. Am I right? Yes, I am right. Okay, so I have got my A cross B vector with this method. I had A bar in the component form. Where is my A bar? Let's go back. This is my A bar, this is my B bar. I got my A cross B vector using the matrix method, and that method, that vector is equal to 4I cap minus j cap minus 5k cap. Okay, now let's see visually what we have got. Our A bar was something, our B bar was something, there was some theta between them, I don't know what it is, but I got this red vector. This is A, this is B. In fact, A cross B will point down, it will not point up. You can use the screw rule, you know, rotate from A to B through the smaller angle, that screw will go down. So A cross B vector is pointing downwards, and this A cross B vector I have got whatever it is. What is it? I got it as what did I get it as? 4I minus j minus 5k. But this is not, what is the magnitude of this? What is the magnitude of this? Since these three components are perpendicular to each other, I can use this formula, 4 square plus minus 1 square plus minus 5 square. If these three were not perpendicular components, then I could not use this formula, as I have been repeatedly saying. But since they are perpendicular to each other, they are mutually perpendicular. Like you pick up any, there is first component, there is second component, there is third component. If you put 1 and 2, if you pick 1 and 2, they are perpendicular to each other. If you put 2 and 3, they are perpendicular to each other. If you take 1 and 3, they are perpendicular to each other. So they should not just be perpendicular to each other, like they should be mutually perpendicular. You pick up any pair, that pair also should be perpendicular. Then I can say that I can use this formula. Okay, so this is 16 plus 1 plus 25, which is 42, root 42, right? So root 42 is the length of this red arrow. So is it a unit vector? Is A cross B a unit vector? The answer is no, because its length is root 42, its length is not 1, right? Now, one more thing. I told you to find a unit vector, if there is a vector A bar, if there is a vector B bar, if you want to find a unit vector which is perpendicular to both A and B, how will you get that n cap unit vector? First do A cross B, then divide that with magnitude of cross product, which is mod A mod B sine theta. But if you have A bar in the component form, if you have B bar in the component form, isn't it tedious to first find magnitude of A, then find magnitude of B, then find the angle between A and B, and then multiply all this? Isn't that too much hard work? Because your A bar is somewhat, what is your A bar? 4I, 2I plus 3J plus K. B bar is I minus J plus K. So if you use this formula, then you will have to first find magnitude of A, which is root 2 square plus 3 square plus 1 square. Then you will have to find magnitude of B. Magnitude of B is nothing but root 1 square plus minus 1 square plus 1 square. And here you will not stop. You will also have to find sine theta. How will you find sine theta? To find sine theta, first you have to find theta, which means what is the angle between these two vectors. And we know that if vectors are in component form, we can get the angle between them using this formula. Cos theta is equal to A dot B by mod A into mod B, right? If you do this now, then you will have to find the dot product of these two. Let me hide myself. I'm first explaining you the lengthy way. So first find the dot product of A and B. How do you get the dot product of these two? 2 into 1 plus 3 into minus 1 plus 1 into 1. That is the numerator, dot product. And then magnitude of A is nothing but root 2 square plus 3 square plus 1 square, which is root 14. and this guy is root 3. Correct? This is cos theta. Now from cos theta you will have to find sin theta, right? And then you will have to use the sin theta here. So isn't it too much effort? First finding mod A, then finding mod B, then finding angle between them, cos like theta in the form of cos theta, and then finding sin theta from that, and then multiplying these three things together. Instead of that, instead of this, what can I do here? I already have the magnitude of A and B, no? A cross B. This root 42, if you first find magnitude of A, then you find magnitude of B, then you find angle between A and B, then you take cos theta, then you multiply this with sin theta, whatever you get, that will also be root 42, right? This thing is also going to give you root 42 only, but I directly got that root 42 because I got the A cross B vector itself. If I got the A cross B vector itself, then I can directly find that magnitude of that vector. No, why should I take this? Why should I take this formula? It's not even needed. So remember guys, do not unnecessarily increase your effort. Make sure you are aware of what you are doing, right? So how do you, finally, what is the answer to my question? N cap, which is a unit vector perpendicular to both A and B, that's nothing but A cross B by mod of A cross B, and this mod of A cross B itself is mod A mod B sin theta. Like I know that mod A cross B and mod A mod B sin theta will give rise to same values, but I will not use mod A mod B sin theta, I will only use mod A cross B. Okay. Hello Shesh, good afternoon. Looks like you are new and here for the first time. Do attend live classes, as I tell every new student of mine. Do not have this habit of watching recorded lectures. So A cross B was 4I cap minus J cap minus 5K cap, right? And root and mod A cross B is root 42, as we got from the previous slide, correct? Mod A cross B is root 42. So this is the answer to my question. In fact, this is an incomplete answer, to be honest, because if your A is like this and your B is like this, then what is this telling you? What is this fellow telling you? This is a unit vector which is perpendicular to A cross B but in the downward direction, right? This vector that you have now, right? This vector is having a unit magnitude but it is pointing down. You can also have a unit vector which is pointing up, no? Because that also will be perpendicular to both A and B. Question has never told you that you are supposed to find only that vector which is pointing down. Both of these can be your answer. So your actual full correct answer is you should take plus or minus of this. You should take plus or minus of this. You should take plus or minus of this. Because when you take plus, then you're taking the down vector. And when you take minus, then you're taking the up vector. So if you write plus or minus, then you're incorporating for both up and down. And that is your total correct answer. Okay. That's all guys, for as far as this question is concerned. I hope you understood everything. If anybody has a doubt, I spent close to 20 minutes to explain this problem. But I felt it was worth it, because if you got complete clarity about everything, then you can use this, then you can start speeding up in the upcoming problems, which I will. The next problem is like this. You have a vector A bar and that's equal to I cap minus J cap plus 2K cap. Then you have a vector B bar which is equal to 3I minus 3J plus 6K. Okay. Now you have to show that A bar and B bar are parallel. Or I can also say check if A bar and B bar are parallel. If anybody has a doubt from the previous problem, feel free to put it in the chat box or in the comment box if you are watching it recorded. I will look at the comments and clear it. Right? So here is your A bar, here is your B bar. Now question, first step is to understand the question. Fine, you have a vector A bar and then you have a vector B bar. I don't know how they look, but I want to see that the question is telling me that show that both of them are parallel, which means It's given in the question that they are parallel. I have to show how they are parallel. How can I show? If they are parallel, that means they will point in the same direction, correct? Or they could also be like this. If they actually mentioned that it can be anti-parallel also. If they mentioned it can be anti-parallel also, then your B could also be pointing back. I don't know. Anti-parallel means they are pointing front and back. Parallel means they have to both point in the same direction. Okay, so it's given in the problem that it's not anti-parallel, so forget about B pointing back. It should only point forward. Okay. Yeah, Akshat, you're right. Cross product can be 0 is one way to prove this. But cross product is equal to 0 will tell you two things, that A and B can either be parallel or they can also be anti-parallel, right? Cross product 0 you don't know that whether they are anti-parallel or parallel if you use that step. So you can check this out, guys. Take A cross B. Once again, how will you take A cross B? Construct the matrix I, J, K. First row. Second row will be components of A. Component values 1, -1, 2. And then B will be 3, -3, 6. You take the determinant of this matrix, that determinant will be 0. Right? You can check that. First, learn how to find determinant from YouTube. And then you will see that you will get something like I into 0 plus J into 0 plus K into 0. You will get something like that, which means it will be a 0 vector. So if A cross B is 0, what does that tell me? What does that tell me if A cross B is 0? That tells me A cross B is nothing but mod A mod B sine theta. And if I get it to be 0, and I can clearly see that A and B are non-zero. A is not equal to 0, B is not equal to 0 because they are non-zero vectors. Their magnitudes cannot be 0 because they are non-zero vectors. That means this sine theta has to be 0. Remember guys, even if one of these two, if one of A and B were 0, then sine theta did not have the compulsion to be 0. But since they are non-zero, sine theta has to compulsorily be 0. If sine theta is 0, then theta can be either 0 degree or 180 degree. Which means your A and B can be pointing in the same direction or they can be pointing in the opposite direction. But what do I have to show in the problem? I have to show that they are parallel. Which means I have to show they are pointing in the same direction. Cross product will only tell me, cross product will get me this far. Cross product will tell me that it can either be case 1 or case 2, but cross product cannot tell me whether it will be case 1 or case 2. Okay, that's why we will not use cross product to solve this. We will use another way. We will use our concept of scalar multiplication on vectors to do this. Right? So if you have a vector A bar, how do you get another vector in the direction of A bar of some other magnitude? If you multiply this A bar with lambda such that this lambda is more than 0, then you will get a vector in the direction of A bar but having a different magnitude. And indirectly I have to show that A and B obey this concept, they obey this relation, right? Because A and B are pointing in the same direction but they are of different magnitudes. So A and B should obey this. So can I say that B bar should be equal to some lambda times A bar where this lambda is more than 0? Should that be the case or not? It should be, right? Because B is in the same direction as A but it has a resized length, right? And also like my lambda also has to be more than 0. That's another compulsion. So B bar is 3i minus 3j plus 6k. And this should be equal to lambda times A. Where is your A? A is I cap minus j cap plus 2k cap. Okay. So look at this guy. Look at this, guys. 3i minus 3j plus 6k is equals to lambda times I minus j plus 2k. Now 3i minus 3j plus 6k, I can multiply with lambda, and then this will be equal to lambda I minus lambda j plus 2 lambda k. Now compare every component. 3 lambda. If these two are equal, if these two vectors are equal, then your lambda has to be 3. Lambda should be equal to 3, right? And let's verify, if lambda is 3, then are other components also obeying it? You have a minus 3 here. If lambda becomes 3, then this will be minus 3. So y components will be equal. And you have a 6 here. If my lambda is indeed 3, which I got from the first comparison itself, then 2 into 3 will be 6. So yeah, z components also will become equal. So indeed, if lambda is 3, then this relation will be obeyed. And also my lambda is more than 0. 3 is more than 0. So I can confirm that a bar and b bar are indeed obeying this relation. A bar and b bar are indeed obeying the relation lambda. If you multiply a bar with lambda, you will get b bar. And this lambda is also more than 0. That also I have confirmed. So a bar and b bar can't be anti-parallel, because then lambda should have been less than 0. Okay. So this is how you do this problem. Cross product will bring it down to both these cases. Cross product will tell you that a and b can be pointing in the same direction or opposite also. But in the question I have to show that they are pointing in the same direction, and opposite is not allowed. That's why we will use this method. Okay, I hope that made sense. Right. In fact, I would like to give you a small note here, guys, a useful note. If you have a vector a bar that's equals to a1 I plus a2j plus a3k, and you have a vector b bar which is equal to b1 I plus b2j plus b3k, then a bar and b bar will be parallel only if a1 by b1 should be equal to a2 by b2 should be equal to a3 by b3, and that should be equal to lambda, and this lambda should be more than 0. Only then they are parallel. And of course they will be anti-parallel only if a1 by b1 is equal to a2 by b2 is equal to a3 by b3 is equal to lambda, and this lambda should be less than 0. Then they will be anti-parallel. So this is the condition for them being anti-parallel. This is the condition for these two vectors being parallel. Okay. How did I get this? I got this from the same concept. Your a bar should be equal to lambda b bar. And then when you compare every component, like you have a1i plus a2j plus a3k, and then you do lambda times b1i plus lambda times b2j plus lambda times b3k, and then when you compare every component, your a1 should be equal to lambda b1, your a2 should be equal to lambda b2, your a3 should be equal to lambda b3. So a1 equal to lambda b1, a2 equal to lambda b2, a3 equal to lambda b3. So this relation itself is giving me this, right? When you divide with b1, you will get lambda. When you divide with b2, you will get lambda. When you divide with b3, you will get lambda. That's how I got this relation. So remember, you can use this trick when vectors are in component form. You can use this to check whether they are parallel or anti-parallel. But anyways, I didn't want you to remember this result blindly. I wanted you to understand what this result means. Okay, moving on. Let's look at the last problem for today. Actually, this is a problem from rotational motion, but I will give this problem to you right away, because the way the problem is written, it's not necessary for you to know rotational motion. And this says, let F be the force acting on a body free to rotate about a point O. Okay, and let R bar be the position vector of any point P on the line of action of force. On the line of action of force. Then torque is defined as torque of this force is defined as R bar cross F bar. Okay. And this torque is about O. Torque about O is defined as, right? Now, after all this information, they have given you the force vector. They have told you that force vector is this 2I plus 3J minus K newtons. And they have told you that R bar is I minus J plus 6K meters. Then they are asking you what is the torque. Okay. Now you have no idea what torque is. You don't know what torque is, but if to be fair, you will never get this question in your actual exam, because this question is first of all telling you what torque is. And in the actual exam, the examiner will assume that you will know what torque is because you would have studied rotational motion by then. Right now you have not studied rotational motion, so the way the question is written is, it is first telling you what torque is, right? And then it has given you the formula for torque, and then the question has given you F and R. It has given you the formula for torque is this. You have to just find cross product of R and F. Okay. So to solve this problem, you only need to know what cross product is. You don't need all this definition. But since it's given, I'll just tell you, if you have a, and don't worry too much about it, we will not spend too much time on this. If you have a body which is, free to rotate about a point O, and if there is a point here where your force is F is acting, right, then this is called as the line of action of force, and you can pick up any point P on this line of action of force, and then this is your R bar, the vector which starts from O and goes to point P. This is your R bar, and this is your F bar. So if you take R cross F, you will get torque about this point O. That is all that that whole paragraph is telling you, right? Maybe you can watch this video later and listen to what I'm saying, but right now I'm not going to explain you, what R exactly is, what F exactly is. You just have to use this to find torque. You have R vector, you have F vector, just use that to find torque. How will you do it? Matrix, construct your matrix. First row will be I, J, K, and then torque is nothing but R cross F. So second row will be components or values of R, component values of R. What are the component values of R? 1, minus 1, 6. So just put 1, minus 1, 6 here. Second, third row is 2, 3, minus 1. The component values of F. So you have 2, 3, minus 1. That's all. That's all. Find the determinant of this now. Minus 1 into minus 1. Minus 3 into 6. Plus J into 6 into 2. Minus of minus 1 into 1. Right? Plus K into 1 into 3 minus 1 into 2. That's all. Right? Your torque is nothing but minus 17I plus 13J plus 5K. This is how your torque is, and its units are in Newton meter. Right? So you will study more about this torque when you study rotational motion. Don't worry about it. But as you can see, the formula for torque requires cross product. So if you haven't studied cross product before studying rotational motion, how will you ever know what this actually properly means? And now you can also get the direction of torque. If you have R, if you have F, then can you tell me the direction for torque? You can. Just join these two vectors by the tail. Join these two vectors by the tail and construct a plane having these two. Put a screw at the common point. Rotate from R to F because torque is R cross F. So rotate from R to F through the smaller angle. This is the smaller angle. Rotate from R to F. The screw will go down. So direction of torque is down. correct? Direction of torque is down. It's a downward vector when R and F are like that. So you can know the direction of torque also if you know cross product properly, right? Tomorrow in some problems, what will happen is, when you study rotational motion, what will happen is, there will be a random problem. There will be a random problem where your R will look like that and your F will look like this. And then you will have to find direction for torque, right? How will you do it? You will have to know cross product properly, right? So you will have to construct a plane containing R and F. In that problem, you will have to construct a plane containing R and F. You will have to put a screw which is perpendicular to this plane, and then rotate from R to F through the smaller angle. This is the smaller angle. Because it's R cross F, that's why you will rotate from R to F. And then you will see that the screw is going like that. It's not perfectly down. It is slightly inclined to that plane, but it's 90 degrees to the plane. But with respect to vertical, it's having some inclination. Like it's not perfectly vertical. Your screw will move in this line, in that line, right? So you will have vectors, in pointing in various directions, some random directions. If you don't know the concept of cross product properly, you will get confused in that direction, in those directions. So if your vectors are, along x, y, z, then it's very easy because we are used to x, y, z. But if my vectors are, randomly pointing here, then pointing there, and then I have to use, cross product. If I have to find their cross product A and B, if I have to find how A cross B will be, then it's not very easy to visualize. That's why you will have to practice the screw rule over and over again until you get used to it. Okay. So that's all, guys. I hope you understood the concepts today and also the problems that we discussed. Let's now quickly look at our intro to calculus. In fact, I will give a proper introduction tomorrow itself, since it's already time. The only thing that I will tell about calculus today is, calculus is used to do calculations. It's used to do calculations for changing conditions. Okay. Let me give you a small example for what I want to tell here. Let's look at the formula for speed. Let's look at the formula for speed. All you guys know, what is the formula for speed? Distance by time. Right? Which means, if I have a body and that body has covered 10 meters in t equal to 10 seconds, then I will say speed of this body is 10 meter per second. Sorry, it's 10 meter distance divided by 10 seconds. So it's 1 meter per second, the speed of the body, right? Hello Ashrit, long time. Seeing your message after quite some time. Looks like you haven't been coming live. Please start doing so if you haven't, because we are starting with calculus now. Alright, everybody, get your alarm clocks ringing. We started with vectors. We spent a good amount of time. We covered so many interesting concepts. If you guys have not caught it, that's probably because you are not attending live classes. Now we are starting with calculus. It's fresh. It has got to do nothing with vectors. Okay. So make sure you start coming live, all of you. Excuse me. Okay. So fine. This is how I will get speed. But let's say if this car was showing some weird motion, like it covered 1 meter, then it covered 2 meters suddenly, then it covers 3 meter, something like that. It's a, very changing sort of a motion. It's not a uniform, sweet 10 meters covered in 10 seconds type of motion. It's haphazard. So if this distance is changing with time, then things become complex. Because according to this formula, I should know that if I'm putting t equal to 10 seconds, I should know that in 10 seconds how much it has covered. Right? So if I take this something like this, if I say that distance has a relation with time. Let's say distance covered by the body is 10t, which means in t equal to 1 seconds this body will cover 10 meter. In t equal to 2 seconds this body will cover 20 meter. In t equal to 10 seconds this body will cover how much distance? 100 meter. So in first seconds it has covered this much, in second second it has covered this much, right? So it gets a little tricky now. How will I get the speed? How will I get the speed? Because formula for speed is distance by time. Now if I want to know the average speed over 10 seconds, then I will put time equal to 10. But can I put 100 meters as my distance? No, I cannot really do that. That's because in the first second your body was having a different speed. In the second second it was having a different. In fact, this is kind of a direct relation. Let me take something like this: 10t square. Let me take 10t square. So in first second body will have covered 10 meter. In second body would have covered 40 meters. In 10 second body would have covered 1000 meters. So it's a little tricky situation because motion is not uniform. It is rapidly increasing. So in such cases my distance is not it's not really a constant with time. It's changing with time. Every instant the speed is different. Like at the end of the first second, average speed is 10 meter by 1 second. At the end of the second speed is 40 meter by 2 seconds, which is 20 meter per second, right? And whereas in the end of first second it was 10 meter per second. In the end of 10 seconds it is 1000 meter by 10, which is it's 100 meter per second. So you can see speed itself is changing. Then how can I use this formula directly? Because distance is not constant with time. So for handling cases like these, we study the concept of calculus. Tomorrow I will bring this example up again, and I will give a slow introduction to what calculus is. But as of now, the only takeaway that I want you to have is calculus is studied for those situations or for those conditions where things are changing. And when such formulas cannot be used, because this formula is assuming that things are constant in a way. Like in 10 seconds body has covered 100 meters, and that's how it's been in the past also. Like motion has been uniform. So tomorrow I will give you a much more detailed introduction about what calculus is. Anyways, I hope you guys have understood to an extent about everything what was taught today, and tomorrow we will look into more things. So take care guys. If there are no doubts, I'll take your leave because it's time already. Looks like there are no doubts. So stay safe, take care, and I'll see you guys tomorrow. Starting with calculus, beware. Please start coming live. Do not have the habit of attending or watching recorded lectures unless it's an emergency. Please have the habit of coming live and asking doubts. Take care. Bye-bye. Stay safe.